Hello, this video is over sections 3.5 and 3.6 in your book, and it is on matrix operations. But before I can teach you how to add, subtract, and multiply matrices, I have to tell you what one is first. So let's define a matrix. A matrix is a rectangular arrangement of numbers in rows and columns. And maybe you've all seen this movie, but this isn't The Matrix. Sorry. So matrices have elements. So each little number in your matrix is called an element. We have rows. Those are always horizontal. So this one has 3 rows, this one has 2 rows, this one has 2 rows. Columns are always vertical. So that's a column, that's a column, that's a column, and so on. And then we always name our matrices with rows by columns. Make sure you know that. Rows by columns. So this one has 1, 2, 3 rows and 1, 2 columns. So it is a 3 by 2. 3 rows by 2 columns. This one has 2 rows and 3 columns. So this is a 2 by 3. This one has 2 of each. So that is a 2 by 2. We always name it rows by columns. That is incredibly important for you to know. All right, so 2 matrices can only be equal to each other if they have the exact same dimensions and the exact same elements. So if I were to set something up like this, you could tell me, well, then x has to be -9, and y has to be -2, and z has to be 6, and then 3 does equal 3. So this is equal now. We could also do more difficult ones like this, where we would then say, okay, so x plus 9 has to equal 7, and we would solve for x. X is -2. And then we know 2x plus y has to equal 1. Minus y has to equal 1, and we've already solved for x, so 2 times -2 minus y equals 1. Solve, and you're going to get y equals -5. So now we would know what x and y are. All right, so now 2 matrices can be added and subtracted together, but only if they have the same dimensions. So here I've given you an A, a B, and a C. If I asked you for A plus B, we would just add the corresponding elements of A and B. And we would have 4, and then 3 and 1 makes 4, and -2 and -5 is -7, and so on. You would just add the corresponding elements. Same thing with subtraction. So A minus B would be 1 minus 3 is -2. I should use there we go. And 3 minus 1 is 2. And -2 minus -5, remember when you do minus negative, you're adding, gives you 3. 4 minus 0 is 4. 0 minus -7 is +7. And -5 minus 2 is -7. Okay, what if I asked you for A plus C? And you might see that on a test. What is A plus C? A is a 2 by 3. And C is a 2 by 2. They do not have the same dimensions. Therefore, you cannot add A and C. It's like adding, I don't know, chickens to oranges. So you would just write not possible and go on with life. All right, now if I had a matrix and I wanted to multiply the whole thing by what we call a scalar, which means we're just going to scale it up or scale it down, we're going to multiply each element by that value. So if I said -2 times matrix A, the same A that we used in the last problem, then I would say -2 times our matrix, 1, 3, -2, 4, 0, -5, and you're just going to multiply each value in each element in the matrix by -2. Like so, easy peasy. And you could do more complicated ones. For example, we could do this. I could ask you for 4 times A plus B. So first you'd have to add A and B, which we already did in the last problem, and then take that and multiply each element by 4. So here I've just copied this from when we did add A and B. And we've got 16, 16, -28, 16, -28, -12. All right, so scalar multiplication is easy. Adding and subtracting is pretty easy. And now here comes the hard part. I'm going to learn how to multiply two matrices together. So to multiply two matrices, the number of columns of the first matrix must equal the number of rows of the second one. So say that to yourself again. The columns of the first must equal the rows of the second. So here I've given you three new matrices to work with. A is 8, 3, 4, 1, B is -2, 5, 3, -4, and C is 6, 1, 2, 4, -3, 0. So the dimensions of A are 2 by 2, 2 rows by 2 columns. B is also a 2 row by 2 column, and C is a 2 row by 3 column. It's very important, like I said before, that you know how to label these. Rows first, columns second. So if I asked you to multiply A times B, if I said, what is A times B? First you have to check and see if it's even possible. And A is a 2 by 2. And B is a 2 by 2. So the columns of the first have to equal the rows of the second. So if you were to write it down, you would just look at these two numbers together. If they're the same, it's possible. We can multiply A times B. There's an L in possible, sorry. And the outer two numbers represent the rows and columns of your answer. Your solution will be a 2 by 2. So if I asked you to multiply B times C, B is a 2 by 2, and C is a 2 by 3. So even though they don't have the same dimensions, because the rows of B equal the columns of B equal the rows of C, we can multiply these. And when we do, our solution will be a 2 by 3. So what if I asked you to multiply C times B? If B times C is possible, C times B should be possible too. But in matrix multiplication, order matters. It does matter. So matrix multiplication is not commutative. You can't move them around because watch this. C is our 2 by 3, but B is a 2 by 2, and these guys don't match. So this is not possible. Not possible. So be careful of that. You have to understand rows by columns, and you have to match up the columns of the first to the rows of the second. And first and second does matter. All right, so now let me show you how to do it. Each row of the first matrix will combine with each column of the second matrix, like so. And I copied this in here because it's nice and color-coded and neat and beautiful. But each A has the row number first and then the column number. So this is A row 1, column 1. This is A row 1, column 2, A row 2, column 1, and A row 2, column 2, and so on. And so what you do is I always circle. You circle horizontally on the first one, and you circle vertically on the second one. So the rows on the first match up with the columns on the second. And so A11 goes with B11, and A12 will go with B21. A11, B11, and we add it to A12, B21. So you just go across and down, A11 times B11 plus A12 times B12. All right, and that's your first element right there. Then for our top row second column, we're going to go top row second column, and we're going to multiply A11 times B12 and put it right there. We're going to multiply A12 times B22 and put it right there and add them together. So across and down for this one, across and down for this one. Remember, we're multiplying and then multiplying and adding those together. So now, I'm going to use a different color. We'd go across the bottom. Bottom left would be our bottom left term. And you take A21 and B11 right here, plus A22 and B21 right here. And then the last thing we would do would be the bottom and the right. So here's our bottom right. And we would do A21 times B12, put it there, plus A22 times B22, put it there. So it's a long process. You've got to make sure you know this process. And I know it's very confusing with all these ugly letters. So let's try one now with some numbers. All right, here's A and B. I just copied the same ones that we've already written, so you don't have to rewrite it if you've got it on your paper already. But if we're going to multiply A times B, then I'm going to write A next to B. And remember, order does matter. A has to come first, B has to come second. Now I'm going to circle the rows of A and the columns of B, and I'm going to combine them together. So we're going to do row 1 and combine it with column 1. So I'm going to multiply the 8 and the negative 2 together and add that to 3 times 3. And that'll be the first term. All right, so that is 8 times the negative 2, which is negative 16, plus 9, which is equal to, I'm setting all this up in a matrix here, which is equal to negative 7. So that's your top left number. All right, now let's do our top right. So now we're going to go with 8 times 5, and then add that to 3 times negative 4. So that is 40 minus 12. And 40 minus 12 is 28, so that's the next term here. All right, let's do the bottom left. So we're going to go 4 times negative 2 is negative 8 times, I'm sorry, I didn't write that right. 4 times negative 2 plus 1 times 3, which is negative 8 plus 3, which is negative 5. And then we're going to do bottom right. 4 times 5 plus 1 times negative 4. And this step right here, you don't have to write that down. You should be able to do that multiplication and addition in your head. But for the sake of the notes, I'm writing it down so that when you go back and you forgot the process, you can look at the steps exactly as I've written them and you go, oh yeah, okay. So I just multiply these and add them. And so then I put it down here. I've got 4 times 5 is 20, plus 1 times negative 4 minus 4. 20 minus 4 is 16. So I'll take this matrix, A times B equals, this one is my answer. And please always circle a box your answer so that I know, because these can get quite messy, where you're done and where the answer is. All right, let's try another one. This time we're going to do B times A, and I'm going to do it faster than I did the one before. I'm going to multiply across and down. So I've got negative 2 times 8 is negative 16, plus 5 times 4 is 20. So I've got 20 minus 16 is 4. Then I'm going to go across and down. Negative 2 times 3 is negative 6, plus 5 times 1. Negative 6 plus 5 is negative 1. Across and down, 3 times 8 is 24, plus negative 4 times 4 is plus negative 16. 24 minus 16 would give us 8. And then bottom right, 3 times 3 is 9, plus negative 4 times 1, 9 minus 4 is 5. So 4, negative 1, 8, 5. And please keep in mind, order matters. So if you look, we just did A times B. A times B does not equal B times A. They're not the same. All right, let's try another one. Let's multiply A times C. So I'm going to go across and down. That means I'm going to multiply 8 times 6 and add it to 3 times 4. And that's going to give me 60. Then I'm going to go top and middle. And I'm going to, so that's my left term here. My top middle term, 8 times 1 plus 3 times 3 is 8 plus 9, which is, sorry, that's a negative 3. I almost missed that. Negative 3. So 8 minus 9 is negative 1. That's your middle term there. And then we're going to go top right. 8 times 2 is 16, plus 3 times 0 is 0. So 16 is that term. And then we're going to go bottom left. 4 times 6 is 24, plus 1 times 4 is 4, so that's 28. And then bottom middle. 4 times 1 is 4, plus 1 times negative 3 is negative 3. 4 minus 3 is 1. And bottom right. 4 times 2 is 8, plus 1 times 0 is 0. That gives you an 8 here. So 60, negative 1, 16, 28, 1, and 8. That is the 2 by 3 resultant of A times C. Okay, so now let's multiply C times A. Push pause. I want you to try to work this one out on your own, and then you can unpause, and I'll help you out. Okay, so we tried it. We went across and down. And wait, there's 3 things here, and there's 2 things here. Remember, this was a 2 by 3, and this was a 2 by 2, and that means that it can't happen. We don't have the right number of elements to match up with each other. So all we have to do is say not possible and move on with life. Yay! All right, the last one I'm going to do is a word problem because I know you can't live without word problems. All right, this says the following matrix represents the inventory of a chain of entertainment stores. So it's like making a spreadsheet or making a list, a table. We've got store 1, store 2, and store 3 for our rows. We've got CDs, DVDs, VHSs, which nobody buys anymore, and games. Then it also says if CDs cost $15, DVDs cost $20, VHSs cost $18, and games cost $30, the cost of each item is represented by the matrix below. And notice that we've got CDs here, and DVDs here, VHS here, and games here. So what was across on the first one is now the down on the second one. And if that reminds you of anything, that's because we go across and down when we multiply. So we're just going to multiply these 2 matrices together, and we're going to go across and down. And if you did store 1's inventory times all the prices, you would just be multiplying CDs times CD prices, plus the DVDs times the DVD prices, plus the VHS times the VHS prices, plus the games times the game prices, would give you for store 1 a grand total of $61,100 worth of inventory. All right, then you could do store 2. Multiplying your matrix, you'd go across and down, and you would multiply 2,600 times 15, because that's the CD value, 800 times the DVD value, 150 VHSs times the VHS value, and 120 times 30 for the games value, and that's all for store 2. So for store 2, we have, class is over. That's okay, I'm almost done. Store 2 would be $61,300. And then store 3, you go across and down, you multiply, 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 and you get $47,170 for store 3. And the moral of this story is when you have to set these up, because if I just gave you the numbers without writing it out for you, you'd have to know, well, I need to make the column, the columns of the first one match the rows of the second one, so that when you multiply across and down, you're combining like things, like that. All right, video's over, class is over. Y'all have a great night, and I'll see you tomorrow.